All right. Hello, everybody, and welcome to the stream. I hope everybody's doing all right tonight. Tonight, we're going to pick up where we left off yesterday with refactoring how our Vulkan descriptor bindings are set up. Our descriptor sets are pretty solid at this point, but the bindings themselves need a little bit of work. And we'll briefly kind of recover why that is and what we're changing from and what we're changing to, right? But before we jump into that, I do want to take just a quick second and thank the supporters of the channel, starting with the partners who are the highest tier of subscription over on Patreon and YouTube memberships. They are Arslia, Gebi Bashir, and Gerboles Inc. I'd also like to thank all the other supporters listed here. They are the other tiers of support over on Patreon, YouTube memberships, as well as Twitch subscriptions. So thank you very much for your support. It is greatly appreciated. And of course, it goes without saying that this channel or this project would not be here without all the support from our viewers. So thank you to each and every one of you who are following along here or over on YouTube. We simulcast here on Twitch and YouTube. So thank you very much for being here and following along with the series. What we're doing here is we're developing a game engine completely from scratch using C and Vulkan. And we are quite a ways into that at this point. And it's time to sort of hit up the refactor tractor a little bit tonight. And so that's what we're going to do. Specifically what we're going to be working on is a little bit of a refactoring around the way that we have descriptor bindings working. So we're going to talk a little bit about the current setup and then the setup that we're going to. And I was able to actually get a little bit of a jump start on this off stream just to kind of get some of the drudge work out of the way so that we could actually get into the meat and potatoes of it. So that is what we're going to jump into now. So let me just make sure that I have this set up correctly. Yep, looks good. All right, so currently the way that we have this configured is we actually have two descriptor sets, right? And so those are basically like here. And so we have one that is global and one that is instance. And global is basically our global type of scene level information, like our projection and view matrix, things like that. And then our instance, you can think of that as material specific data, right? So data that needs to be updated per material, like our textures, and our surface information, things of that nature. And then we also do have a local one down here that is push constants, but that's kind of a separate thing, so we won't be discussing that. That implementation works as designed. So the big two that we're going to be changing are these two. And so our descriptor sets are basically our global and our instance. And then within each one of those descriptor sets, we have two bindings currently, right? And so those two bindings, the first one is for a uniform buffer object, right? Or just our buffer data. And so that typically will contain, like I mentioned before, our view and projection matrices, as well as any sort of global level scene data. And then we also have one for combined image samplers, right? Image samplers. Samplers. All right. And, this is obviously combined to make textures, right? And so that's the way that it's currently set up right now. And the way that this works is this here is actually an array of those things, right? So we have an X number of samplers, and those are all fed into the global level as an array. Now, we are not currently using global texture bindings for anything, so we're not actually using that code at the moment, but we're going to refactor it anyway so that when we have a shader that needs that, we'll have it available. The instance also has two bindings, right? And it also has one binding for a UBO, right? And this contains our instance, our material instance level data, right? And what I mean by that is the individual properties of a specific material. So like maybe the glossiness, for example, or some property like that, right? And right now that's under a bit of a refactor because we've got a PBR system that we just built. We need to add some properties to it, but that's the kind of stuff that goes there. And then just like global, we have image samplers, right? And these are combined image samplers in terms of Vulkan, right? And this is also an array of X number of images. And so the reason that we went with this setup was so that in our shader, we could do something like, if we take a look at the PBR shader, for example, so that we could do something like this, right? We have all of our samples here in one nice array, right? And we were trying to do something called descriptor aliasing, which was basically to say, okay, well, for the same set and binding, I want to use different sampler types. So I have this array of sampler 2Ds called samplers, and then I also have this array of sampler cubes called cube samplers. And they both fit in the same set and binding. And as far as Vulkan's concerned, there's no difference under the hood in terms of how these are actually used. And we had to do a little bit of work to actually get this to work, but the problem is this is a very, apparently a very limited supported setup. So one big caveat to that, unfortunately, is this doesn't currently work on Molten VK, which is the translation layer that we use for Mac OS. And apparently it did work at one point, and there's been a regression, and now it doesn't work. So because of that, I've decided to sort of go against this route. And we're going to have the ability to separate these samplers out while still maintaining the ability to have arrays, right? And so what we're going to wind up with instead is we are essentially going to have our two descriptor sets as we had before, right? And we're going to have UBO as the first one, if it exists, which so far it always exists for every shader that we've written, right? But then what we're going to have is we're going to have X number of descriptors, or bindings, I should say, sorry, for samplers, right? So if we had 4 samplers here, we would treat those as individual samplers, right? Or individual bindings. And then we're also going to have the ability to treat one of these as arrays if we wanted to. So this one could be treated as, just a sampler 2D, right? Whereas this one could be, let me undo this actually. So this one could be a sampler 2D. This one could be like a sampler cube. And then this one could be a sampler 2D array with like 4 entries in it. And so forth, right? And so we can have all these bindings available to us. Like this could be a sampler 3D, for example. And we have lots of different options here, right? And the point of this is to have this flexibility in how we actually declare these things in our shader. And it's also going to allow us to have a much more flexible setup when it comes to our shader configuration, as well as separating these things out and not relying on that descriptor aliasing. So in this case, this would be, this descriptor set would be index 0 for global, and index 1 for instance, right? And so this same setup would be down here, right? You could have a whole bunch of these guys as well, right? X number of them, right? And so the way that this would work is our binding indices. If there's a UBO, it would be binding 0, and then this would be 1, 2, 3, 4, etc. Right? And it'd be the same thing here: 1, 0, 1, 2, 3, 4, etc. Right? And however many of those we have is what we wind up with there. And so we'll have the ability to dynamically determine this per shader. And this will actually allow us also to configure the pipeline and the memory allocation under the hood to be dynamic as well, so that we're not sort of generating these huge structures of data that we'll never actually wind up using. So that's kind of where we're going for tonight. Jack Pop, thank you for the follow. I appreciate that, and welcome. Hope you're doing well tonight. So yeah, that's what we're going to implement tonight, and I've already got kind of a head start on it. So we'll take a look at the work that I've done so far on that, and then we'll just kind of continue in the implementation as it were. I do want to remind both sides, Twitch and YouTube, we are simulcasting, and I do watch both chats. So if you guys have any questions along the way, or just want to stop in, chat, say hi, whatever, as long as it's semi-related to the channel and relatively PC, it's all good, right? Okay, so that's all the intro stuff out of the way. So I want to give a quick example here of what we're thinking of switching to in terms of how these things are defined. So for right now, I'm only going to support array setups for uniform samplers, right? But what we're going to wind up with is something that looks a little bit like this in our shader config. And actually, I can pull up the terrain one. Let's see that one as an example of how it looked before. So you'll see here that we have all of our samplers sort of defined like this, and these all just kind of get jammed into an array, right? And they get jammed into the same array. And so we see that our uniform type is samp for all of these all the way down, and it's not explicit as to what type of sampler it is. It's just that's what it is. And so what we're going to have is the ability to change from something that's like this to something that's a little bit more explicit. So, for example, we have 3 bindings in this particular shader for our textures, right? So the first binding, you can think of this as our binding 1, if you were. So this is of type sampler 2D, and it's an array of 5 of them, right? So it's our albedo, normal, metallic, roughness, and AO. And so this under the hood represents 5 descriptors, but it occupies 1 binding, okay? And so that's at the instance level, and it's called material textures. So this will show up in the shader as an array of 5 textures that are 5 sampler 2Ds, rather. The shadow map itself is a separate sampler 2D array of 4 textures, and that's called shadow textures, right? So rather than having to do shadow texture 0, 1, 2, 3, now we just have this. And then our IBL cube, right? So that's our irradiance map, essentially. We should probably rename that, but that is a sampler cube, and it's a singular one, so there's no array here. And so that is called IBL cube texture. And so we'll have 1 binding for this, 1 binding for this, and 1 binding for this, right? And so that's kind of the direction that we're going to be headed in. And eventually I'm thinking we'll probably extend this array logic to regular uniforms as well. So right now we're kind of having to hack this a little bit. This is an array in the actual GLSL, but for right now we have these split out. And so we'll probably extend this logic to regular uniforms as well. But for right now I just kind of want to get it working with samplers, right? So this is all revolving around samplers. Okay, so I think the best way to show the diff is actually probably going to be in here, because I can quickly kind of go in here and look at the differences. So we had to add a couple of string utility methods. So we've added a string starts with case sensitive and case insensitive check. So we can basically say, does string 0 start with string 1? And that's you'll see the use for that in a minute. And then down here, we also have a string parse array length. So if we pass a string, similar to what we have in our shader file, of sampler 2D 4 with the brackets here, it can actually parse that out and say, okay, well, this is the type of that, and then, but specifically, what is the count of the array? So it looks for this particular character set and then says, what is that, right? And so we're going to use that to parse the array length out of that string. And then, of course, that returns Boolean as to whether or not it was successful. And if it was successful, it writes a length to this out length. Okay. Renderer utils. We just added a quick check here. In fact, let me come back to that because it'll make more sense if we look at this first. We've added shader uniform types. So before, all we had was just a shader uniform type sampler, and we treated all samplers as the same. And that was part of the problem, right? So now we've actually split this out, and we have a sampler 1D, 2D, 3D, sampler cube, 1D array, 2D array, and cube array. And we might eventually wind up changing this up. But one thing I do want to point out is we can have an array of sampler 1D textures, an array of sampler 2D textures, an array of sampler 3D textures, and an array of sampler cubes. That is not the same as a texture array, right? Or a texture array, or an array texture, I guess. They are actually different things. They're treated differently in the shader, right? So a texture array or a sampler array is completely different from an array of textures. So I just want to point that out. And so those will have to be handled separately within the shader, as well as our Vulkan code will actually have to treat that a little bit differently as well. Okay, so we have that. So one other thing that we added while we're here is when we're setting up our shader uniforms, when we're reading in that shader configuration file, one thing that we can now parse out of that is array length. And so this will obviously be 0 if it's not an array, or if it is an array, it'll have a length populated there. So that'll just kind of tell us that. And then one other thing that we have in our shader config is the maximum number of instances allowed for that particular shader. So that was kind of something that I forgot to mention in our shader config. Whereas this was sort of a hard-coded data field within the Vulkan renderer itself before, this has now been exposed. And the reason for this is we can kind of get an idea based on the shader how many instances we're ever going to have. And so for some shaders, we may not have instances at all. We might only need global variables, and so we don't need any instances. Versus something like materials, right now we can have 256 materials in the system before we actually have a problem, right? And we can just expand this number here, and it'll just grow behind the scenes, right? And so this is a much easier way to control that, as well as have a lot of control over how much memory gets allocated per shader. Right now, that number was hard-coded to, I think, 1024 for every single shader, which was obviously just way overkill for most shaders. And so now we can actually define this explicitly. And the default for this is 0. So if you don't specify it, then the shader doesn't support instances. Okay? And so we'll add some code around that as well. Okay, so the renderer utils basically takes in a shader uniform type and says, hey, is this a sampler? And all that is literally just a switch case. So if it's any of these uniform types, it's a sampler. Otherwise, it's not. And then we did some work in shader loader. So actually, okay, our default, I guess, was 1 instance, right? And so in our shader loader itself, we have that default that's now added. We added a field for that to be able to parse max instances, so we can extract that from the config file. And then down here, this is where we are actually parsing all the sampler types. So if the string starts with samp, then we know it's going to be some sort of sampler. And so the next thing we do is we check to see if it's an array type, and we use this string parse array length, and we feed it the field's 0, which is the entire name, right? So it might be For example, the field is going to be this guy right here, right? So it'll be mat4, or it'll be, if you come down here, it'll be sampler cube, or it'll be sampler 2D, right? That's what gets fed in there. And so, right here. And so it looks at that and says, okay, based on that, do we have an array or not? Set the array length if so. And then if it is an array, we go ahead and get the first part of the string that's before the brace there, right? So just one character before that brace. And that'll give us the actual string value that leads up to that. And then we can take that and use it. Or otherwise, it just takes the whole string. And so at that point, we then do a string equal check for each of the known types. So we have our sampler 1D, 2D, 3D, cube array, 1D array, 2D array, and cube array. And one thing that we did also is for sampler 2D, which was kind of our default sampler type, we've left in the ability to read samp and sampler as we used to have from the old version for backward compatibility, right? So we don't break that. So any shaders that are still configured that way should still work. And so what that does is it just sets the uniform type to that known sampler type. And that's it for the loader, right? It wasn't a whole heck of a lot. Nothing complex there. The shader system got a few small updates as well. So the uniform add, we did away with the is sampler because we can derive that from the type. And now we take in array length when we actually create that because we have that ability. And so if we come down here, we have this uniform type is sampler check. So we don't need the is sampler bool anymore. We can just check the type. And then here in the uniform add implementation, again, we just have this is sampler that's done in here, and then we extract the array length. And that's pretty much it from the front end of it, right? Most of the work for this is going to be in the back end. And so the shader system, the shader uniform just received a array length field update there. Vulkan types, I'll hit this really quickly. This is kind of a work in progress, and this is kind of where I left off. So we had this concept of max shader bindings because of this old model that we had. Right, we only ever had 2 bindings before for each, right? So we could just assume that, and we used to have a hard-coded array for that, right? And so what we did was we did away with this hard-coded array, and now we have a dynamic array of bindings. And then we also have a sampler binding index start because we may have a UBO or we may not have a UBO. And so if we don't have a UBO, then this would become 0, right, instead of 1. Whereas if we do have a UBO, right, then this is 0 and this is 1. Okay, so that's the difference there. And max instances is also saved on the Vulkan shader config, so we just take a copy of that. And then we have 2 new fields in here. We have the global sampler indices and the instance sampler indices. And these are the uniform indices as we're processing those arrays. We'll see that in the actual code, right? So that's kind of where we are, and then the backend changes are just kind of supporting that, right? So what we have here is, if we scroll down, we did a little bit of cleaning up here. So before, we had this hard-coded max descriptor allocate count of 1024. We've done away with that. And now we use the actual counts of the actual shader, the configured shader to achieve this. So first off, we get the frame count, which is 3 if you're triple buffering, 2 if you're double buffering. And so our swap chain image count will tell us that. We have the max sampler count, which is basically one set of globals times frame count. So that's going to be 3 because there's, wait a minute. I'm sorry, global samplers per count, right? So if we have 1 sampler, that's going to be 3. If we have 2 samplers, that'll be 6, right? And then we have that plus the instance count, right? So it's the max number of instances times the samplers per instance times the frame count, right? And then we have the max UBO count, which is just the frame count because there's one for global, and then max instances times frame count, so 3 per instance essentially for us, right? And then the max descriptor allocate count is the max UBO count and the max sampler count. So we're dynamically determining that now, so that we can actually set that up and allocate the appropriate amount of memory for it. So we build out the configuration, and basically what we do here is we save off the max instances to the internal shader config. And then, let's see, I think this was just a formatting. Some of these are just formatting changes. I think that's a formatting change as well. So is that. These are formatting changes. Some of this stuff was on multiple lines and really didn't need to be, so it's just formatting changes here. And then down here, when we're getting the uniform counts, what we do is we create a D array for the sampler indices for global and instance, right? So we create 2 D arrays for that. We added some comments here for clarity. And then as we're looping through all of the uniforms that have been configured and read out of the shader reader, we say, hey, if it's a sampler, increment that count, but also keep track of its index in the global or instance sampler array, right? And that allows us to quickly look that up later. So let's see, this are config pool sizes. This was one of the places where we were actually able to utilize that new data. So instead of having hard-coded numbers, 1024 and 4096, which were just kind of pulled out of my ass, to be honest, we now have actual counts, right? So we have a max UBO count for the UBO descriptor type, and then for the combined image sampler, we have max sampler count, and they're accurate now, right? That's a formatting change. And then the other thing is this bindings, where that is was just a hard-coded array of 2. Now it is actually dynamically allocated, right? So we've kind of got the global descriptor set configuration going on here. So we determine our binding count here, and then allocate an array for our bindings, and then fill those things out. So we start off with a binding index of 0. If we have a global uniform count, then we have a UBO, and that is set up here. So I just added some comments here just to kind of clarify some of this. The other thing is we had this sort of hard-coded concept of stage flags, right? So these would have been accessed or accessible rather in the vertex and fragment shader stage. I've gone ahead and just allowed it in all, right? I don't see a reason not to, at least at this point. And it's certainly not going to slow anything down measurably, right? So we go through that, we increment the binding index, and then we set the binding, the sampler binding index start to whether or not we had uniforms. If we had uniforms for global, it's 1, otherwise it's 0. And then we loop through our global uniform samplers. So for each one of those, we say, okay, go ahead and look up the uniform itself based off of that indice or index that we saved off before. And so we grab a pointer to that, and we say, hey, what's its array length? If its array length is less than 1, then we're going to use 1. If its array length is greater than 1, then we'll use the array length. And this way, we have the appropriate number of descriptors for this particular binding. And so that's how we handle arrays versus not arrays. And again, we just change this to stage all, and that's pretty much it, right? We have this left off comment here as to where I left off. A couple more things down here, just small items, I think. Let's see, where is this one? We renamed this to sampler binding index start. That's probably going to need some attention. And I think this one down here is the same thing. Where is it? Where is the change line? Here it is. That's a formatting change. Okay, so that is pretty much, that gets us caught up to where we were. So let me go ahead and catch up on chat here. Smudge, how's it going? Good to have you here. Good to see you. Jock Pop morning. Yep, nice. Oh, we have ads. Okay. Well, we'll be right back then. I like to pause the stream whenever we have ads. That way that nobody actually misses content while there's ads up, right? So I know over on the YouTube side, you guys don't generally get as many ads over there, but on the Twitch side, we get ads every 30 minutes for 90 seconds. So I'd like to pause the stream so that way nobody is actually missing content on the screen. So we're about a third of the way through that, so we will continue here just in a moment. All right. Also gives me a chance to hydrate. Lazy Engineer. Currently speedrunning your series after dropping off a while back. Just stopping in to say hi. Well, hello. Welcome. Good to have you here. I think I've seen some of your comments on the videos over on the YouTube side, so I recognize the name. I think I'm actually following you on YouTube, I believe. Or subscribed. It is over there. Yeah. But hello. Welcome. Good to see you. All right. Got about 5 seconds left. All right, ads are dead. So now we can kind of get on with it, right? So let me just move my tablet over here. And let me just finish catching up on chat here. You mean good morning? Yeah, fair enough. Do you wish me a good morning or mean that it's good morning whether I want it or not? Fair enough. Yeah. Whatever it is, whatever time of day it is in your location. Yeah. That's fair. Okay. So, now that we're caught up on that, let's go ahead and jump into the Vulkan backend. Backend C. Okay, so we were kind of just tying up some stuff here with the global descriptor set configuration. So I just want to take a look through this. So we have a binding count of 1 for the UBO, and then the global uniform sampler count. Okay, so that makes sense. We allocate that array. We go through that if need be. For the UBO, that's always going to be just one descriptor. And then we loop through each configured sampler. Okay, I think this is good to go. So, let's see, descriptor set count is 1. So let's see, our descriptor set count is based off of, so if we don't have any global variables, that's technically we don't have a descriptor set here, right? So I think that makes sense. I don't think we've actually run into that yet. Okay, so this, let's move this to one line. I'm also going to focus on some formatting, right? Because at some point my auto formatter was foobar and kind of screwed some things up. So let's see what we did up here. I'm actually just going to grab this and put it down here because we basically need the same logic in both places. I probably could make this generic so it doesn't really repeat, but right now I'm just interested in getting it to work. So our set config is, instead of global uniform sampler count, this should be instance. Okay, and binding count. Okay, so that makes sense. So if we have, oh wait, I think we needed a, we also need this guy. So we're going to track the binding index externally here. And instead of incrementing this binding count every single time, we are going to increment the binding index every time. So this is going to be Vulkan shader stage all, because I don't want to restrict that anymore. Let's move that up. Let's move this up. Let's see, binding index, that makes sense. I think we're all good there. Hey, this looks really cool. I've only messed around with OpenGL. How does Vulkan compare? Ooh boy, that's a loaded question. Basically, a first-time chat, by the way, super welcome. Basically, Vulkan is a much more explicit API. So OpenGL kind of hid a lot of state under the hood for you and kind of managed a lot of those things for you. Whereas Vulkan kind of offsets that to the responsibility of the application. So it's a lot more verbose. There's a lot more things to set up, a lot more ways to shoot yourself in the foot, but you have much more control over how things are set up and how to tune things and so forth. Whereas in OpenGL, a lot of that control was lost and kind of handled by the driver under the hood, and you really had no control over it. So benefits and drawbacks to everything, right? All right, so basically what we're doing now is like something you would never have to worry about on OpenGL. You don't really manage descriptors on OpenGL, but you manage descriptors on Vulkan, right? So yeah, it definitely is interesting. And it's, since switching to Vulkan, I definitely have a much better understanding of how graphics pipelines work than ever before, for sure. You kind of learn it the hard way, but that's the best way to learn it, I think. Do you have a YouTube channel with the series? Yes, I do, actually. I think it's... Let me just link that for you. So there it is right there. Thank you for the follow. I appreciate that. So that YouTube series, or that YouTube channel has this whole series on it. So this actually started off a couple of years ago as a YouTube sort of tutorial series, and it morphed over time away from sort of being a tutorial where we go over every single line of code and stuff like that to this sort of live stream ad hoc format where we kind of develop things on the fly. So you'll see that whole series there. I forget how many videos it's up to at this point. So this is episode 157. And so there's probably, I would say there's at least 160 videos in that playlist, because there's a couple of things where I had to like patch stuff and stuff in between. But yeah, that's all there. It's all documented, as well as, and I'll just take a quick second to point this out. Let me pull up this. Oops, I didn't want to close that window, but okay. I guess I will use this one. So we also have this website, which is kohiengine.com. So I'll drop that in the chat as well. And so I'll drop this in YouTube chat as well. And so what this is this is sort of the main hub for the whole project, right? And so we have links to the YouTube channel, the Twitch channel. It's even down here. There's actually an embedded Twitch stream, so I can like wave to myself, hello, right? And so, yeah, look at that. Inception. And so basically this has links to everything. So we've got auto-generated API documentation available here. We have links to the source code on GitHub, links to Patreon, all that good stuff. A Discord server that's got 700 plus people on it. And the GitHub, this is completely open source, this project, right? So it's 100% free. There will never be any charge for the engine. There will never be any royalties for the engine. It is Apache 2.0 licensed, which means the only thing you have to do if you use it is basically say you used it. That's it. So you can use the code however you want. You just basically have to say, hey, I used Kohi. That's it. Yeah, it's 100% free. It's open source. It's all available right now. Everything that we've developed is checked in and updated here. We are currently working under the feature PBR branch right now, right? So cool. Absolutely awesome, man. I hope to tune in more often. Mostly just a lurker, so I'm enjoying from the shadows. That's totally cool. I appreciate that. And welcome. It's great to have you here. I appreciate the support. All right. LSR, hello. How's it going? Good to see you. Welcome back. All right. Why is this window so gigantic? I hate when Windows does this. It like blows these windows out of proportion and just makes them absolutely huge. Okay. So, bindings. So we've got this one straightened out. We do need to set up the index binding start, or the binding start index for samplers, rather. So that should be this, except instance uniform count. Wait a minute. Yes. Okay, that makes sense. I had to think about that for a second. I thought I might have had it backwards, but no, that's correct. Okay. So this is the UBO binding if it's used. Why does it say global? That should say instance. Copy pasta issue. And then add a binding for samplers if used. So this is going to change to, you know what, basically this. Let me actually just grab all of this, and we'll just swap out the code, right? So instead of that, this is going to be instance. So if we have uniform samplers, this is going to be the instance uniform sampler count. Instance sampler indices. We're going to use the binding index, which was declared up there, so that's fine. Yeah, I think that's okay. Array length. So we're either going to treat it as an array or a single. Combined image sampler, all stages. Binding index. Okay, I think that is good to go, right? So we can get rid of this left off. And so that's our bindings set up. So we should now have proper bindings. But I know that there were a couple of other places where this was hard-coded. Invalidate all instance states. So see, this is another place where we had this magic 1024 number in here, right? To-do dynamic. So you can get rid of that to-do because we're going to handle that now. So instance states, let's see, I think internal shader. I'm going to guess that this was the other thing that we had that is probably just not right. So let's take a look at Vulkan shader. We have instance states, so yeah, this was another thing that was hard-coded. All right, so we have this Vulkan max material count, which is hard-coded to 1024. We no longer have this. We no longer need this many, right? So we're going to get rid of this and make this dynamic as well. So we can calculate that based on our configuration now. So we'll have that. We'll need to set that up as well. Did I should probably just delete that define, actually. Let me undo this real quick. And I'm going to remove this. Vulkan max UI count. UI control instances. Is that even used anywhere? I'm going to delete it, because that seems like a legacy thing that should be gone anyways. So I'm going to remove that too. Okay, here we go. So max number of textures allowed at each level. I'm okay with those limits for now, I think. I should probably get these from hardware instead, but I think I'm okay with these limits. These are probably what's guaranteed by the spec. Max uniforms, push constant ranges. I think I got most of these from the spec, about, based on minimums. So that should all be fine. And so we can delete this and turn that into a dynamic array. Okay. So now we should be good to go ahead and edit that. So this is going to wind up being, let's see, that's going to be, where did I get that? Internal shader. Internal shader. And this is going to be instance, max instances, I think it was going to be. Max instances. So we go through all instance states and invalidate those. Which actually, we need to allocate that memory because it's dynamically allocated now. So we'll say internal shader instance states equal to k allocates size of Vulkan shader instance state, that's the one I want, times internal shader config max instances. I should probably shorten that a little bit, right? And we'll say memory tag array. All right. So now we've allocated that. We should be good to go there. Are you using GLM and GLFW, or does Vulkan have their own substitute? So, I'm not using either one of those. We have our own math library that we wrote from scratch. And GLFW is sort of the windowing platform layer, and we're not using that either. We rolled our own, right? So if we take a look here in our file explorer, right? If I go under engine, source, platform, we have a platform Linux layer, a platform Mac OS layer, and a platform Win32 layer. And then some shared code across like the Unixes, right? And so we actually have implemented our own version of those things. Posture check. Thank you, Coffee Lava. Appreciate that. My posture kind of sucks sometimes, so thank you. Appreciate that. Super dope. Yeah, I'm definitely going to check out this awesome work. I appreciate that. Yeah. Currently, the reason that we're doing all this stuff is because this is actually broken on Mac OS right now, which is also the reason it's still in a feature branch and not in the main branch, right? So, yeah, there's that too. I'm doing my best to hopefully never break the main branch. It still happens because there's hardware setups that I'm not aware of, but hopefully next year I'm going to be able to get my hands on some different hardware setups to be able to test stuff. Okay, so our internal descriptors, I think, are straightened out this way. We've got our instance states. These will all be zeroed out already by our kallocate, so I don't have to worry about that. I just need to set the state IDs to invalid ID so that I know which ones are freed. Let's see. We copy over the call mode, topology types. Okay, so that's it for shader create, actually. And so destroy, actually, we have a couple of allocations that are going to have to be undone. So let's see. Once we do... Let's see, the instance states. I'm going to need to free that. That's probably going to be towards the end. Let's see, here's the uniform buffer. Descriptor pool, I could probably do it here. So what I'll do is I do a k free. And I'll say the block is internal. Oops, I don't have, do I have an internal shader block here? I don't think I do. Oh, it's just called shader here. Okay. So shader instance states. And the size of that is going to be this. And this is just going to be shader. And then the memory tag for that was array. I hate hitting the F1 key brings that up. It's so annoying. I need to unmap that. Okay, so nuke the instance states. All right. Also, there was another one. So for each, let's see, the set config. Internal shader config descriptor sets. So I guess I need to free those too. Let's see. Descriptor set count, descriptor set layouts. We're just releasing the Vulkan resources here. That's still, I'm okay with leaving that as 2 because we're only going to have 2, the global and instance, so that should be fine. Where's the set config? So that is the shader config descriptor sets. Descriptor set count. Okay. Shader config. Do we have anything else here in the config being changed? I don't think we do. So let's go with shader config descriptor sets. Yeah, that makes sense. Sub-I bindings is something we need to free. So those are of type vk descriptor set layout binding. So we need to do k free. And then size of vk descriptor set layout binding. There it is. Times shader config. Let's see. Max instances? No, not max instances. Which one of these do I want? Max descriptor. I think it was descriptor sets sub-I again. Binding count? There it is. Okay, so we have that, and then mem tag array. All right, so we free that so that we don't leak that memory. I think that's everything we need to handle for now. I'm not so much worried about this because this mostly happens during shutdown. We're not really going to be unloading shaders dynamically a whole lot. Once they're loaded, they're kind of loaded. So, let's see. I appreciate the Yar bongos, yes. So I was watching some of the first videos in your playlist where you started this project. I was using your build scripts as a guide. Did you move forward using make as the code base grew? I'm currently just using scripts, but it compiles everything every time. Yes. So we did fix that. But yeah, we did actually continue using make. So there are, all the way down here, we have 2 make files now. One is for making executables and one is for making libraries. And then we have these build debug and build release scripts, which invoke this build all with some arguments. And it basically just feeds through, and that's sort of our build system, right? So we can turn on and off different things that we want to build, but ultimately they all go through one of these 2 make files, right? And this does take dependencies into mind, so it doesn't build everything every single time. So we did actually fix that. You're building DRM GUI, which takes a long time. Ooh, yeah, you don't want to do that. Yeah, I mean, if you're, depending on how you're doing your dependencies, you may want to actually set that up a little bit differently. But yeah, the whole reason I set this up is because I didn't want to use CMake. Yeah, build systems make your head spin, mine too. They're just needlessly complicated. And I don't care what it is, every time I see a project that's like, that uses CMake, there's always some sort of problem with it. It's extremely rare to actually have it work the first time around. Especially if you're building on Windows and you have to use Visual Studio, forget it. That was one of the reasons that I used Clang as the compiler front end, so to speak, right? Is because it's the same configuration across cross-platform. You just link different things basically and include different things. That's basically it. So yeah, but that's basically the answer, right? We did eventually switch to something more robust. We iterated on it a few times throughout the series, so it does get better as you progress, right? We kind of build on that. Recently noticed the code gives deprecation warnings with LLVM above 14.6. LLVM 17 is the latest. I mean, errors, not warnings. Is that on the current version of Kohi? Like because I know I made some changes a while back for some of that stuff. I think, what am I on right now? I was just looking at some Vulkan spec stuff. I think it's Clang version. Yeah, I'm on version 15 at the moment, so I should probably upgrade that sometime soon. On latest, okay. Yeah, so I'll have to look into that. I'm going to write that down, actually. There might be, I'm guessing they got a little bit more strict with some stuff that I was probably getting away with and shouldn't have been. Okay, so let's see. What next? You're currently using GCC and ran into an issue between Windows and Linux earlier at the boilerplate stage. Yeah, probably. I was pretty loose on some of the compilation rules in there, and so Visual Studio had different requirements than GCC. GCC is a little bit more strict than Clang by default with some things, and so there were some issues there for sure. But it should mostly work. There might be some minor modifications that you have to make it work on GCC, but it shouldn't be anything like it's just syntactic stuff, I think. Incidentally, by the way, if you ever run into that kind of stuff and want to make a pull request, you're more than welcome to. With changes like that, right? The worst I can do is review them and say no, right? But more than likely, I'll if anything needs to be adjusted, I'll tell you such. Okay. All right, so I'm not going to worry anymore about the destroy for right now. I think we're good on that. I am going to fix some of this formatting now because some of this is kind of foobar. Okay. So initialize is probably another place that we're going to have to hit because this is actually what loads the shader modules and all that stuff. So before we were kind of building up a configuration that this stage then uses to actually instantiate all this stuff and acquire resources, things like that. So some of this is going to be formatting changes because, again, my auto formatting rules have changed over time and some of this code hasn't been touched in a very long time. So it's like stupid stuff like this. That's just on multiple lines that really doesn't need to be, right? Okay. So we convert our types to the Vulkan ones. I don't see any issue with that. This is just for attributes. We have ads. So just for you guys that are new to the stream, we pause for break, an ad break once every 30 minutes for 90 seconds. Twitch runs those ads. I know on YouTube you guys don't likely get those ads, but over on the Twitch side, people do. And so I don't want anybody to miss content, so I like to pause the stream, right? Get some water too. I wonder if my bot is awake over on YouTube side. Sometimes it just takes forever to actually start working for some reason. I don't know why that is. Got about 30 seconds left, and then we'll be right back into it. Okay. 15 seconds. All right, and ads are dead, and we're back. Diamond, good evening. How are you? Good to see you here. Welcome. Okay, so I think what I'm going to do is basically just kind of comb through all the shader code that's in here and just make sure that all of our sampler logic is actually up to date. And our binding logic is up to date. So this is attributes. I could skip that stuff. Descriptor pool. Pool size count is 2. That makes sense. We set up our configuration for our pool sizes before, so that should be fine. Here's the result. The VK result here. Let's get that on one line. Let's get this on one line. All right. Sari Shimo, first time chat, welcome. Watching with interest. I'm starting my first Vulkan project soon. Awesome. Glad to hear that. I've got the Vulkan programming guide and I've done some hello worlds, first triangle, texture triangle. Awesome. That's great to hear. Any advice for a beginner getting into grips with Vulkan? Yeah, I would definitely take a look at Sasha Willem's Vulkan examples repo. Because he's got basically just examples of how to use all the different features of Vulkan in there. That's a really good example to take a look at. And I would say I would focus more on keep all your Vulkan code in one spot as you're adding features, and worry about the separation and organization of it later. Especially since you're learning the way it works. If you try to sort of compartmentalize it into all kinds of different structures and classes and things like that, you're quickly going to realize you're going to have to refactor that stuff a lot. And so I would say keep your Vulkan code all in one place, in one file if you possibly can. That way everything's super easy to move around. And worry about abstracting that stuff after you actually have everything working, right? Because a lot of times you'll think that you have your head wrapped around a particular concept, and then you'll realize later on, nope, not so much, and you have to refactor it because it doesn't work exactly the way you thought it did. At least that was my experience with it when I was learning it. So that's probably the best advice I can offer there. I hope that helps. Okay. Like, I think, for example, like, I've had to refactor the way descriptors work a couple times. Just due to that, right? Just due to kind of the way that that I thought that they should work versus the way that they actually should work. Am I using tmux plus lazyvim? So if I was on Linux, I would be using tmux, but I'm on Windows right now. But I'm actually using westerm, which actually is a terminal multiplexer as well. So it kind of looks tmux-ish down here, so I can see why you thought that. But this is NeoVim with a custom configuration. So I actually have a link there to my NeoVim setup, which is basically this right here that details the whole thing. This is a little bit out of date, but it details my entire setup here, right? Cool. Yeah, no problem. Okay, so descriptor set count. So this is what I am thinking of. So we need to create our descriptor set layouts. So our descriptor set count should almost always be 2, right? I guess it'd be 1 if you're only using global uniforms or samplers, or otherwise 2. That's fine. The descriptor sets are going to have the same... Let me think about that for a second. Yeah, it should be the same. So there's always going to be a single binding for UBO if it's used, and then multiple bindings for image samplers. So this all should translate over because we're using the direct count of that. So here's the binding count and the bindings. That should carry over. We already had that sort of dynamic, so that should be good. That's just dynamic now instead of being hard-coded. Let's see, binding flags. I don't think I need to change any of this stuff, actually. So we have UBO and samplers. The binding flags we have here for the partial binding, which I might wind up actually undoing this. Just because we're not really going to need it anymore. So actually... wants to undo partial binding because it isn't really needed at this time. Can't type tonight. All right, cool. So that's our binding counts, binding flags. Wait a minute. This is going to change. This is going to change. This is going to be dynamic. So maybe we don't do this as a 2D. Maybe we change it now. Sarishima, thank you so much for the follow. I appreciate that, and welcome. So we no longer have a hard-coded limit of 2 bindings anymore, right? We could have any number of bindings. And actually, technically speaking, this was wrong. Because we might not even have a UBO for this. So we were only using these binding flags for the samplers. I think I'm gonna remove this now, actually. 1 second. Somebody is whispering me something. Okay, so I think the only reason I would actually need these is for the extended info, which only has this. Layout info. Yeah, I think I'm going to get rid of this. I don't think I need any of that. Because we're not going to do partial bindings anymore. And in fact, we should probably look for other places where that exists as well. So the only thing we need to know is the binding count and the bindings at this point. Okay, so we go ahead and create that descriptor set layout. We do that for each one. That should be fine. Okay. Let's see what this to-do is. Feels wrong to have these here, at least in this fashion. Should probably be configured to pull from someplace instead viewport. We can set this dynamically, so this can be overridden at any time. So I think this is just like the default stuff in here. So I'm actually going to update this comment because it's not 100% accurate. Default viewport scissor can be dynamically overridden. Yeah, I'm fine with that for now. All right, stage create infos. That is mostly fine as well. Stage count, we create the infos for each of the stages. That's fine. This is all topology stuff. Don't think I need to mess with that. Attribute count, attributes, descriptor set layout. Okay, so these are the layouts. That all looks dynamic. I don't think any of that's hard-coded, so we should be fine. Let's get that on one line. Okay. That should be fine. All right. To figure out what the default should be here. This is topology stuff. I'm not going to touch this for right now. There is a to-do there. But I'm not going to touch that for right now. I don't want this change set to be too wide. We get the uniform offset, buffer offset alignment. That should be fine. So we have the global UBO stride and then the UBO stride for instances. That should all be fine. Okay, max count should be configurable, or perhaps long-term support of buffer resizing. Oh, okay, so this is another place that we actually had a hard-coded material count. So this was kind of a weird thing, a leftover of something that I put in early, where we kind of base this on materials, but we then later switched to the sort of instance thing. So this should actually be, what is it, config? Nope. S is internal shader? Yeah, it's a shader. I thought we had... Global UBO, let's see. Offsets. I thought we had... Global texture maps, no. I could have swore that we actually had that in here. Didn't we copy that over from the config? Did we not? Alright, do we have the internal shader here anywhere? Let's see, we do have internal shader, so I can use that. So let's do internal shader, max, or was it config? Max instances, there we go. We can delete that comment because that's no longer needed. Okay, so now we're doing this based off of the actual number of max instances we can have. So the total buffer size is going to be the global UBO stride, because there's only one instance of that, plus the instance UBO stride times the number of max instances. So that's now dynamic, which is good. Okay, so none of this should need to change. Okay. So we allocate for the global UBO, which should be fine. That doesn't need to change. Map the entire buffer's memory. Yeah, that's fine. Allocate global descriptor sets, 1 per frame. Global is always the first set. Yes, that's true. So that can remain the same. There's always going to be... Wait a minute. Do we... This is 1 per frame, but it shouldn't necessarily be 3. Technically, it could be more than that, right? But I don't want to change it now because that's kind of outside the scope of what we're doing. So I'm going to put a to-do. And this should be dynamic based off the number of swap chain images. And I'm pretty sure that this is an actual issue on Linux under the Mesa drivers. Because there's some stuff here that I have to do around that. So there's that, and then there's also this down here that has the same issue. So I'm going to keep that there for now and just mark it with a to-do, because we do need to come back to that. But I don't want to do that now because that's much, much bigger of a change than I want to do as part of this. Level Up Design, hello. Welcome. I'm doing pretty good. How about you? Can't complain. Getting stuff done, you know? Definitely can't complain, right? So I think that's it for initialize, so that's good. So we've got that set up. Use, I don't think needs to change anything. Bind globals, shouldn't need to change anything. Bind instance. Wow, what is with the funky formatting here? Fix that. That should be fine. It just sets an offset internally, so that shouldn't be a big deal. Applying the globals. This is probably going to be one thing that we need to change. So the UBO is not going to need changing. If needs update. Global descriptor sets. Image index. So content image index context. This is the swap chain image index. So we're selecting the global descriptor set of the swap chain index. That makes sense. Buffer info. But we might not need to update this, right? Because what if we don't have this? I think this was actually, this was a bug that I noticed. Like, if we don't actually have global descriptors, like, or global, a global UBO, we probably shouldn't be doing this. So, this is where that start index comes into count, right? Because we've got some hard-coded stuff here about that too. As well as this, right? So we need to fix that. Blake Booyah. Appreciate the follow. Thank you so much and welcome. Yeah, lots to do for sure. Yeah. Definitely lots to do. But that's okay, right? This is kind of something I've known I was going to have to do for a while. And so I'm glad to step in here and actually kind of get to it. Hi, do you like mathematics? Sometimes yes, sometimes no. I'm no math wizard by any stretch of the imagination, for sure. And if you see, like, my streams from last week where I really struggled hardcore with some matrix math bugs, sometimes it's really annoying. Serious Coder, thank you for the follow. I appreciate that. Welcome. All right, so we really need to determine if we even have a UBO to update first. So let's take a look at if compiz, thank you for the follow. I appreciate that. Welcome. So if internal config actually, is this what I want? Instances, descriptor sets. I don't think that's actually what I want. Global uniform count. There we go. If global uniform count is greater than 0, then we have a UBO, and we want to do this. So UBO right. Let's do this. So only update if there is actually a UBO. Okay. Desc binding array element, those can be 0, that's fine. Descriptor count is 1 is fine. Because if this does exist, it is going to be first, so that's fine. However, descriptor writes global set binding count. Implement global image samplers. That's a to-do. Remember when I said we didn't use image samplers at the global level? I wasn't kidding, because we actually don't have it implemented, which is suboptimal. So probably what I'm going to do is implement the changes at the instance level and come back and just drop it in here. So I'll leave that for now. Al Hallison Dev, thank you so much for the follow. I appreciate that, and welcome. Glad to have you here. Okay. Binding count. Yeah, let's do this first. And yeah, I'm gonna come back to this. We're gonna do the instance one first, okay? Because I know this one works. So we have the internal. If the uniform count is less than 1 and the uniform sampler count is less than 1, then we do not use instances. I guess I see where that makes sense, right? I guess it makes sense to check that. So if we're drawing something from the application and we're saying, hey, apply instance, and we don't actually use instances on the shader, we should probably bleat about that, right? Okay. So, I'm just going to fix a couple formatting things here along the way. So, if needs update, descriptor writes, always a max of 2 descriptor sets. I don't think that's right, though, because these are bindings, not sets, right? And we always had 2 descriptor bindings. So that comment's actually wrong. This is bindings. Oh, wow. Wow. Let me respit all that out, right? Bindings. There we go. So this assumption here is not correct. VK write descriptor set. Or actually, is it? Write descriptor set, destination binding, descriptor type, descriptor count. Right. And then we just feed these. So we sort of build up these descriptor writes. And then do them all at once. So Vulkan image. So in this case, we loop through the total sampler count, set these things up, and then, okay. So we're going to have to change all of how this works, actually, which is kind of what I expected. So, we had 2 descriptor writes because we had one write for the UBO, and then the second write was for the single sampler array that we essentially had. And we were plugging the number into, let's see, this image infos. Image infos. Where did we declare that, actually? Max global textures. Oh, that's interesting, too. It's using max global textures for instance images. Okay. That's special. So, yeah, that's here. So we'll have to fix that too. This should be max instance textures. Which I suppose that's fine. Although now I don't know that we're actually going to need that. Muted? I don't think so. Oh, reloaded. Okay, pebcac, yep. Or ebcac, yep, fair enough. Fair enough. Yeah, I was going to say, wait a minute, I'm muted? No, but I'm looking at my audio levels are good, so. No worries. Welcome, by the way, Gnarly. Welcome. Okay, so let's first off, let's do this. So, we're going to iterate our samplers. Actually, can we even do that yet? Determine if an update is required. Yeah, we didn't finish up here yet. Okay, I got ahead of myself a little bit. So, needs update. We're probably going to have to change this, I'm thinking. But we'll see in a second. Instance generation. All right. We'll get that to determine if an update is required. We should probably have some sort of dirty flag, by the way, to help determine this. Although that's kind of already done here. So this is... You know what, I'm going to do away with this, because we're already kind of checking that. We were saying check the generation if it's not equal. But we're kind of doing that externally now and have this, I guess, so... So if this is... This stuff is memory mapped anyway, so I don't think I have to do descriptor writes on this all the time. So I'm going to do this. Okay. So we'll set the buffer, offset, and range. We'll set up a write descriptor set for the UBO descriptor. That shouldn't need any changes. Descriptor count ++. Descriptor count is up here. Why do we have index and count? Oh, this is, I guess, write count versus descriptor index. So update sampler count, descriptor count, ++. Okay, so when we come down here to actually update the descriptor sets, we use the update, or we use the descriptor count, which is really a write count. So let's rename this descriptor write count. Right? That way we know how many are actually written. It's a little bit more explicit. Material generation, some generation from somewhere. I guess whenever we update this, we should probably check that generation, right? I think this is what all that was referring to. I don't really think that's valid anymore, because the UBO only really has to be updated once. So we might actually be able to get rid of the instance UBO generation, to be completely honest. But again, that's kind of outside the scope of what we're doing right now, so... Okay, so this all looks pretty good. Now we iterate the samplers. So the sampler binding index is the descriptor set index instance, which is always going to be index 1. Yep. So we have the sampler binding index start. Oh, we have ads. So for those of you who are new to the channel, I do like to pause for ads whenever they come up. So on Twitch, they are scheduled to run once every 30 minutes for 90 seconds. And so I like to just kind of take a quick pause and let those ads run. So that way that nobody misses content along the way, right? So we're just kind of going to let those run. And we'll be back here in less than a minute, right? Gives me a chance to get some water too. And Sajivan, I will answer your question when we come back from the ad break, right? I know you're on YouTube and you guys don't really get ads the same way, but I will wait for the Twitch side. We only have 30 seconds left, and then I'll answer that question. Okay, and we are back. Ads are dead. So, yeah, I just like to pause the stream while ads are running so that any folks on Twitch don't miss the content. So, Sajivan, I hope I pronounced that correctly. Sorry if I butchered it. Asked the question, if we dynamically allocate some memory block, what is the default value to them? So, ordinarily with malloc, you would just get rubbish data in there, right? But the way that I have our allocator set up is it also zeroes that data whenever you allocate memory automatically. So whenever you get memory within this engine, you automatically get zeroed out memory. And I did that for the purpose of never having to worry about garbage data, right? Okay, so we have sampler binding index, which is the sampler binding start. Total sampler count for this is going to be the descriptor count under bindings. Sampler binding index. So this is where we're actually going to have to change things up, because everything was under one binding index, which is not necessarily the case now. So let's see, how do we... Let's rename this to sampler binding start index. So the total sampler count is that. Wait, that's descriptor count. That's actually not accurate either. So we're basically going to have a separate binding for each one of these, but potentially multiple descriptors within that. So we need to rethink how we're going to do this. So we actually need to iterate through the sampler counts and then get the bindings for each one of those sampler counts. And if those bindings have more than one descriptor count, then we iterate those. Okay. Okay. So I guess at this point, this is actually where we would start our loop. So we're going to say for U32. I don't want to use I because we're already using that down here. So I'm going to use S for sampler. Equals 0. And then S is less than internal, whoops, instance uniform sampler count. Then plus plus S. So iterate each sampler. And then what we're going to have to do is we're going to have to grab the uniform. Actually, do we need to grab the uniform? Because we would have already set that here. So maybe not. So then what we'll do is we'll say U30, actually we'll take this, paste it here, but we're going to rename it to binding sampler count, because that's really what that is. And then let's see, we have sampler binding start index. So the actual index is going to be S plus sampler binding start index to offset it by that. So that means our binding here, instead of sampler binding start index, is going to actually be index. Right? And so what we're doing is, the reason that we're doing this is because this might either be 0 or 1. So if we're iterating through all of our samplers, we could be starting at 0 or 1. But I don't necessarily want to do that here because that'll mess this up and I'll have to offset this by that, and that just seems messy, right? So I could just offset the actual index here by that, and then use this as the actual index to our binding. I guess I could rename that to binding index. A little more clear, right? Okay, so the image infos, I think the image infos are actually used per binding, I believe. Let's see. VK write descriptor set. So we're going to need one of these write descriptor sets per binding that we update, which is going to be this descriptor index and descriptor set. And then image infos. Yeah, so we're going to need one of those image info arrays per iteration of this. So we'll yank that from here, put it here. And I'm okay with keeping this same amount there. I'm fine with that for now. Let's see. So now we need to iterate the binding sampler count. So we'll say for, let's see, what do we want? I guess U32 descriptor, I guess, right? We'll call it like descriptor index, U32D equals 0. D is less than binding sampler count, and then plus plus I. And then looping through each one of these, we should basically be at the same point that we are here. So update sampler count. So I think we're going to need that there. And then, whoops, I put I here. That should be D. And so actually, I think most of this logic is actually going to wind up being there with the descriptor right at the end of it. So let's actually just grab all of this. And this actually goes here, minus this loop, because we already kind of have that. So I can get rid of that and one of these guys here, I think. That looks correct. Yep, okay. So we iterate each sampler binding. Wait a minute. This is each... No, that was each sampler. The bindings are in here. This is why comments can be misleading if you're not careful, right? Each... Wait a minute. So each sampler there... No, this is sampler bindings. Each sampler binding. This is each sampler descriptor within the binding. Which for most cases is just going to be one, unless it's an array. So this is the binding sampler count. Which actually this should be binding descriptor count. Okay. Only update in the list if actually needing an update. Okay. So here's where we get the texture maps from the instance states on the bound instance ID. Now the instance ID use of undeclared identifier. Oh, because I used S here, didn't I? S is used as a shader, I think. Yup. Let me change that real quick. So I'm going to say SB. Sampler binding. All right. And then this is going to be SB. Okay. That makes more sense. Okay. Instance texture maps. So this is going to be sub D, I believe. So I'm going to have to think about the way that the texture maps actually work. Because this is not going to be a flat array anymore either. So this isn't quite a one-to-one relationship. Because what we had before... let me do a split on this and open up the terrain shader config. So what we had before was just a bunch of samplers listed off, right? Just a bunch of samplers like this. And they weren't grouped in any way, shape, or form. They were just kind of one after the other. But now we actually have groupings, right? So in this case, we have a grouping of 5 samplers that are material textures that are all under one binding. We have shadow textures that are grouped as an array of 4, and then we have this IBL cube, which is just a standard texture. So we're actually going to have to update our texture map to, or our instance states to actually include that. Because I don't see how we're going to, unless we keep that kind of information in the texture map itself. That would be the only way we could actually map that. I'll have to think about that for a second. Only update in the list if actually needing an update. So, oh, okay. So what this is referring to, by the way, is we're actually setting this every single time, and we don't actually need to be. Once it's set, unless we update the texture. And actually, technically, it's if we change the map. I think. Otherwise, it'll just use the same view, right? So it should be fine. This is a problem I didn't think of. So how do we map, then, our instance texture maps to binding indices? That is an interesting conundrum. So when we set up the uniforms, we have, this is basically considered one uniform. So maybe if we tie the, instead of instance states, instance texture maps, we have instance states uniforms, and we tie the texture maps to the uniform. Then we can iterate it this way and still kind of have what we need. I'm thinking that's probably what I'm going to have to do. I hope that makes sense. Okay, so let me actually spec this out just in comments real quick, and then I'll actually have sort of a list of things I need to do. So instead of a flat list of texture maps, the instance state should have a list of uniforms, uniform samplers, each with their own list of texture maps associated with them. This will make for fast lookups assignments here. Okay, so that means I'm going to have to change up instance states a little bit to tie these things together. Which means when we set up an instance, we're going to have to also do that. So if we peek definition on this, we have the instance state. Peek definition on that. Here we have our instance texture maps. So this has an ID and an offset for the instance data. The descriptor set state, which might also actually need an update. Yep, that actually needs an update too. Shoot. So the descriptor sets for this instance, one per frame. To do handle frame counts other than 3. That's going to be another thing we need to address later on. And then we have descriptor states for each one of these things, which is max bindings. So this is also going to have to be a dynamic array. Which is going to have to be allocated. So that's per descriptor. So the descriptor probably, if we peek definition on this, I think this is literally just generations and IDs. Identifier per frame, typically used for texture IDs. Okay, so this is the mapping of the texture ID and generations to determine whether or not we've updated that thing or not. So this should probably also be tied to the uniform. So we have the descriptor sets themselves. One per frame. And then the states for those things. So technically this whole descriptor, wait, the whole descriptor set state? No, these are the descriptor sets. These are for the individual descriptors per descriptor. Which now I'm thinking probably ought to be extracted out of there as well. Okay, so what we need is a new structure, I think. Let's call this Vulkan instance. Them likes, thank you so much for the follow. I appreciate that. Welcome. Hello. Just learning C, and I was wondering if you've given qualifiers register, volatile, or atomic in your project just to see a real use case. I've actually not used any of those. so no. Maybe at some point, but yeah, not at the moment. Pop Nemo, Yar Ito. I like those emotes, Ruche. I prefer picnic, problem in chair, not in computer. Ooh, I like that one. I haven't heard that one. That's a good one, Smudge. I haven't heard that. Okay, so we have Vulkan instance, uniform. Do we call it state? State, I guess? Question mark. We'll call it that for now. Vulkan instance, uniform. Oh, this should be uniform sampler state. We don't do this for all of them, right? It's just samplers. Yeah, I think that makes sense. Okay. Christoph Cook, thank you so much for the follow. I appreciate it, and welcome. How are you doing tonight? Them likes just got here. What kind of game are you making? So right now we're making a game engine, which is just kind of a generic engine at the moment, but we're going to use it for 3D games. So at the moment, I'm rewriting the logic for descriptor handling when it comes to specifically sampler descriptors and the Vulkan backend. And the reason I'm doing that is to make the system a lot more flexible. So unfortunately, that means the code is currently broken and I can't run it at the moment. But we are developing a game engine from scratch. So we are developing the Kohi game engine. And so this started off as a YouTube tutorial series and has now kind of gone over and been converted to a live dev stream. And the whole thing is available on GitHub. So it's here on GitHub. We're currently working on a PBR feature branch, but you know, this is kind of what that page looks like at the moment, right? This is 100% open source and free. It will never cost any money. It will never cost any royalties or anything like that. There will never be any of that stuff. It's 100% open source, Apache 2.0 license, which basically means if you use the code, you can use it however you want. Just say you used Kohi. That's it, right? So that's kind of what we're doing. And also we do have things like auto-generated API documentation as well, right? So there's all kinds of things in here, right, for our individual stuff. So there's that. So yeah, cool. That's kind of what we're working on. Yeah, it's actually really cool. Yeah, I think so. I'm really liking the way the project's coming along. It's been a lot of work, but yeah, it's coming along good. I'm happy with it so far. Okay, so in the sampler state, we probably ought to have no, not sampler, uniform. Shader uniform is what I'm looking for. And we're going to take a pointer to that because I don't want to store the actual uniform here. I don't want to store a copy of it. We're going to take a pointer to that. And we're going to call this just uniform, I guess. And then what we'll do is we will hold on to our texture maps there. Whoops. We'll hold on to our texture maps. We'll take these and move them over here. We use the struct type because that's apparently not declared yet at this point in the file, I guess. Okay, so we have the instance texture maps. We're going to rename that to uniform texture maps, which might just be a single texture map. It might be multiple texture maps. Depends on whether or not it's an array of textures. So should we set that as a D array so we can kind of dynamically move those things? No, I don't think so. I don't think we need that. But what we should track as well, actually, I think the uniform will have that information in it as far as how many texture maps are there. So we might actually be good on that. So that should be connected to that. State for the descriptor set. Descriptor set state. I'm wondering if we should get rid of this structure, actually. It's kind of weird the way these two things are bound together. So this is the descriptor sets for the instance. One per frame. And then this, I think, is actually right here. Descriptor state, which handles updates for those. So we have descriptor set state. And we only have, right, we have one descriptor set for the instance. I think I'm going to get rid of that and actually simplify it, right? Because it's actually not doing us that much good anymore now that we've kind of split some of this stuff out. So let's take this and put it, where was that? Instance state. Let's replace this with that. Right, and then we can get rid of this. It's just one more level of stuff we don't need. And I just realized I'm probably actually coding behind the camera, which is actually not cool. So let me actually save this and quit out of this one. That's in Vulkan types. So let me open up Vulkan types. I'll open it up over here, actually. I can quit out of this one, and let's go to let's see, uniform texture maps. Yeah, this is right where we were. Okay, so the instance state is now descriptor sets themselves, which makes sense. And then we have the descriptor state for those sets, I think, right? So that's the individual descriptors, which these do make sense to group that way. So this is per descriptor, which turns and handles frames. Count is managed in shader config. Okay. Oh, we have another ad break. Okay. So for those of you new to the stream, I like to actually pause the stream when ads come up, just so that nobody misses any content. So that's generally 90 seconds every half an hour. So I just like to go ahead and do that. And yeah, I know the YouTube side doesn't get ads like Twitch does, but I ask that you guys bear with me, right? Let's see. No Mercy, love from India. Awesome. Hello and welcome. Welcome to the stream. We've got about little over 30 seconds left on the ad break, and then we can kind of get back to it, kind of, sort of. Hydrate in the meantime. All right, ads are dead, and we're back. So, I think we'll probably go a little bit longer. Normally, this is right around the time I end the stream, but I'm going to go a little bit longer tonight. Not too much longer, but a little bit, right? So, we have the descriptor states for the individual descriptors themselves. Let's see, where is the... So the count is actually... Let me split that. This actually should be split per line to a few lines. So count is managed in shader config. All right, which makes sense. So I think we can get our count from that. I don't think I need to worry too much about getting a count and maintaining that. So instance state now has, wait a minute, did I nuke? Did I actually accidentally nuke my... Oh, no, I didn't. I just haven't put it in yet. Okay. So I need to put my uniform sampler state in for all of the uniforms for the instance. Which actually, we should probably lump these descriptor states within that as well. Right along with the uniform texture maps, because the texture maps are going to be one-to-one with the descriptors. So let's actually take this, move it to here. Because it kind of makes sense to group those things together. And then we'll say Vulkan instance uniform sampler state. And we'll say sampler uniforms, I guess. Right? And that'll be a dynamic array. The number of which we can also get from the shader config. So that shouldn't be an issue. And I think that's how we'll manage it, right? So each instance itself has a state with an ID and an offset into the uniform buffer. We also have the descriptor sets for that instance, one per frame, right? So in this case, 3. We have a to-do to handle that. And then we also have the uniform sampler states for all the uniforms of, all the sampler uniforms of that shader state. Maybe we should just... I wonder if we should actually make this non-descriptive or non-specific to samplers. Sampler uniforms. We should probably just make this uniforms. Right? And then maybe this will exist if it's a sampler uniform. I think that makes sense. Let's keep it a little bit more generic. So this will just be called uniforms. Okay, and then, yeah, we'll basically create one of these per uniform. And then that'll actually give us what we need to operate over here. So for each binding, let's see. So we iterate the samplers, then we iterate the sampler bindings. We get the binding descriptor count from that binding. I'm thinking we should probably iterate the uniforms instead. Think about that for a second. Do we want to do that, or do we want to do them in order? So we have the instance states, bound instance ID. Let's get that further up, because we don't actually need to reach into that array every single time here. So let's do instance states. That's going to be iterate samplers. That should probably be up here somewhere. Oh, we actually have it up here. It's known as object state, which is kind of a relic of leftover stuff. So I'm actually going to rename that instance state. Okay, that makes sense. I don't know why I didn't get this one too. Right. Okay. So we'll have to descriptor set state, descriptor states, descriptor index. Okay, so we might have actually broken this in the process, but we'll have to come back and fix that. So if this is descriptor index 0, wait a minute. So the shader we might not be able to actually do this. We might not actually be able to do this exactly like this, because we actually do need those descriptor states for the UBO as well, which aren't tied to uniforms. Poop. How am I going to link those two then? So we are going to have a single descriptor state for the UBO, but then the rest are going to be uniforms. Oh. Actually, let's split them up. Right? I think that actually makes sense, because I can then just have a UBO descriptor state, and then all the other ones can just be lumped under this thing. So let's actually switch this back to uniform sampler. We will make this sampler specific. Call this sampler uniforms. So for sampler uniforms, we'll get it this way. For the UBO, the UBO is all one descriptor. So I can literally just pull this, put it here, and then UBO descriptor state, which may or may not be filled out. So the descriptor sets do need to remain where they are. And then this is a mapping of sampler uniforms to descriptors and texture maps. Okay, that's how we'll split those two up. So this becomes, instead of descriptor set state, we have UBO descriptor state. Right, and then we can get rid of this, the descriptor index included, and then get that. And that fixes that. Okay, cool. Enjoyable Freshman, thank you so much for the follow. I appreciate it, and welcome. Welcome to the stream. All right, so we have that. Descriptor index ++, which does make sense. Okay, so if we have uniform samplers, descriptor set index, yep, okay, so that all still holds true. Instance uniform sampler count. Okay, so if we go through this, config descriptor sets. Okay, so this is the binding count. For the bindings for that. Let's see, is this? I think this is a descriptor set config, right? Yeah, it is. Okay, let's separate this out. It's a little bit more obvious as to what it is. Descriptor set config, and we'll call this set config, is equal to that guy. Actually, did we already have this somewhere? I could have swore we did. Nope, but this is actually wrong. This should be instant state. Oh, here's another one. Object descriptor set. This should be instance descriptor set. We used to call it objects back in the day. And I think that's just there now. Okay, this is instance descriptor set. Did we finally get them all? I think. Okay. Okay. So we have the bindings, binding index, binding descriptor count. So that should be set config. That'll give us that. But should we actually iterate by that? I don't think we should. We should iterate by the uniforms instead. So let's take a look at that real quick. So we can say, I guess we could grab the sampler uniform count first. Which is actually here. So each binding index. Okay, so Vulkan instance uniform sampler state, binding sampler state equals the address of what is it? S dot internal, I think is what we want. internal dot instance states s dot bound instance ID dot sampler uniforms sub SB. Okay, yeah, that makes sense. I thought we had don't we have the instance state? I think we just fixed that, didn't we? Yeah, we already have that, so I can just change that to instance state. All right. Okay, so we take the address of the instance state sampler uniforms sub SB. That'll give us the binding that we need for that particular state. I'm not sure that we're actually going to need this. Descriptor set instance. We actually have that up here as well. Okay, so let's actually move this up here. And then we can actually shorten this line too. To set config. Okay, so we take the binding index, which actually I don't even know if this matters now. But okay. So binding descriptor count is going to be set config bindings binding index descriptor count. So I guess that makes sense. And then for binding descriptor count, that's going to be how many texture maps we actually have. So that's going to be internal instance states. So instead of that, it's going to be binding sampler state. Binding sampler, binding sampler state. And then uniform texture maps, sub D. I think that makes sense to iterate it that way. Okay. Sensor effects. Hey, how's everything going? I missed the stream yesterday. Yeah, no big deal. So yesterday we actually got our shadow maps working correctly, and we also got our cascading shadow maps in. And so that's all up on the PBR branch now. And today we're actually reworking the way that our descriptor bindings work. Because it wasn't quite as flexible as what we needed. And the way that I was doing it before is broken on macOS. And it kind of relied on a hack anyway. So we're currently refactoring that. So yeah, that's kind of where we're at on that. So I'm in the middle of that refactor now, where we're basically going to have multiple sampler bindings available, so that we can do stuff in our config, like, for example, our PBR shader config is one I've already edited. So we can do things like this, have a uniform with a sampler to the array of a given size and actually read it in and treat it that way, as opposed to having, just massive amounts of samplers just listed here, right? And that'll actually allow us to update the shader code to look very similar to that as well, instead of relying on all that aliasing stuff that we were doing before. So this is going to be better in the long run. It's also going to wind up saving us a lot of memory, because I'm changing the way that all this stuff is allocated internally to be more specific to the shader, so that we only actually allocate the memory that we need, as opposed to huge pools of it that we ultimately don't wind up using most of. So that's kind of what we're doing now. Okay, so and right now I'm hooking up instance samplers and basically restructuring this sort of this backend to map descriptors and texture maps to uniforms. So that's kind of what I'm in the middle of. I think all of this, rest of this logic is probably just going to work drop in for this whole part. Because at this point we have everything that we need to do the things that we need to do, except for the texture right, or the sampler rights down here. So we have the image infos right here. So with each descriptor within the binding, we add to that. So our iterator here is D instead of I. I did that just to see all the differences as we step through it, so that should be fine. Change up descriptor state to handle this properly. Sync frame generation if not using a default texture. Don't we do that somewhere? I thought. I'm going to leave that to do. I might come back to it. All right, so this is update sampler count. And this is what needs to change. So descriptor write count is going to be plus plus. Our descriptor writes, I think, was just an array of 2. Which is freaking wrong, right? So basically we need to recalculate that. And we're going to need to dynamically allocate some memory for that, I guess. So we are going to say we're going to allocate enough space for everything that we need. And then we'll use what we need and throw away the rest afterwards. And it's got to be dynamically allocated, unfortunately. Because we have no way of knowing how many we could possibly use. I suppose we could allocate like a massive number of descriptor rights, right? Ultimately, we have this image infos max instance textures, right? So I suppose we could just use that. And then add 1 to it. I think that's what I'm going to do, actually. Because I really don't want to dynamically allocate this, because that's slow, right? And we do this a lot per frame. So, let's do, what was that called? Vulkan shader max instance textures. Okay, so max instance textures. Max of 2 descriptor bindings, that's no longer true, so we can delete that. And then this should actually be, I'll put the 1 here, so 1 plus that. Allocate enough descriptor rights to handle the max allowed textures per instance. Right, and even though that's kind of a lot of, I mean, it's not really that much memory, right? This struct isn't really that large. Right, that's all that structure is. It's not very big. So I'm not too worried about that, okay? So we'll do, instead of times 2, we'll do 1 plus Vulkan shader max instance textures. Okay, so we'll write that. And I realize technically this could overflow, but I'm not really concerned about it, right? Because technically we could use all of those under 1 descriptor, or 1 binding. So I'm not really too worried about that. Okay, so update sampler count. So this is the destination set is going to be the instance descriptor set. The descriptor index The descriptor index. Let's see. The descriptor index is where? Sampler descriptor index. Where is that defined? Update sampler count. So this is I'm trying to think if I need to move this in the loop. So we have all the image infos. No, this is correct. This is where it's supposed to be. So sampler descriptor. Destination set. Here's the descriptor type. Image infos. Descriptor index. Where is that defined? Descriptor index is 0. If we have a uniform buffer, descriptor index is incremented. Okay. Implement iterate samplers. Binding index. Do we actually increment this anywhere? I don't see where we actually increment this. Probably because it was only the second one we never had to bother before. So this should probably be incremented per binding. This descriptor index is not quite right. Let me see. So that's being used, the destination binding. So that's really a binding index, not a descriptor index. No wonder that was kind of confusing. All right, so we've got a binding index there. So we're considering each one of these samplers in terms of the uniform a single binding. So the binding index is here. Of course, now we've renamed this. So I guess we could just use... I guess technically we don't even need this line because we actually have it above. Instance uniform sampler count. So here's where we actually iterate it. So at the end of this loop is where we need to put that in. Actually, no. Yeah, binding index. Okay. Binding index plus plus. That's where it needs to go, right? So we create this descriptor right. We set it in here. And then we increment the binding index. Now, this is if instance sampler. Okay. So I think this logic should be good. Okay. I don't think we're missing anything here. All right. So descriptor write count, if that's greater than 0, we go ahead and do the writes. Otherwise, we bind the descriptor sets, which this is instance descriptor sets. Okay. I think we finally have all that straightened out, I think. So now that we have that, we actually need to straighten that out for the global descriptors too. Of course, I guess I could just leave this here, but I feel like while we're in here, we should probably just straighten it out, right? So Oh, we do actually need to do this. We have ads. So just for those of you who are new here, we do like to break for ads whenever they come up on the Twitch stream. So those of you on the YouTube side, I know you don't get it. I know everybody on Twitch doesn't necessarily get it. It varies by region and locale, but every 30 minutes we're served with 90 seconds of ads. So I just don't want anybody to miss sort of what we're doing here. So I like to pause the stream during that ad break, right? And so we've got about 40 seconds left on that ad break, and then we can get back to it. And we can and continue, right? And straighten this section of code out, right? There are samplers to be written to support this. So that's what we need to do next. We've got about 20 seconds left, and we'll get back to it. All right, about 10 seconds. All right, and ads are dead. So thank you guys for standing by during the ad break, and welcome back. We will continue. Fluffy Quaternion, first-time chatter, welcome. How are you doing tonight? I hope you're doing well. Welcome to the stream. So we're very much in progress of just refactoring the way that our descriptor bindings work, just to make it a little bit more flexible. And we actually, I think we're about half done with that. Maybe a little more. And so basically we've refactored our instance level, bindings. And so now we actually need to do the same thing for global. So the UBO is always first. If we have that, we do the descriptor write for that. So descriptor writes 2. This is no longer going to be hard-coded to a 2. That's going to be dynamic. So we'll move that up here. And then, let's see, what did I do for descriptor write set? Down here, I think I did this. Max, okay, so I'm actually just going to do that same thing, but for globals. So let's go ahead and set that up. And I'll just change this to max global textures. All right. So the next thing that we need is we actually need a descriptor index, I think is the next bit. Binding index, rather. So we'll have a descriptor write count and then binding index. So we'll take those. That is going to be the same. Right? So this actually up here can go, whoops. This can go up here. We use binding index, right? Which is technically always going to be 0 here, but we'll use it anyway. And then we'll increment this. So binding index plus plus. Which technically speaking, this should be binding index. All right. We're always going to have a descriptor count of 1 because it's a UBO, so that's fine. All right. Global set binding count. Okay, so this is probably what we're going to just, frankly, probably just nuke and replace with what we've done down below. So update descriptor sets. Let's see, descriptor set, device, descriptor write count, which is global set binding count. Descriptor writes, and then copy count and descriptor copies. Okay, so that's probably going to be correct. Descriptor set binding count. Yeah, I think that's going to be correct. So we don't actually need to mess with that. I think it's just going to be this section here. So what I'm going to do, actually, is I'm going to cheat a little bit. Instance uniform count. Are we actually doing that for globals? Yeah, global. Okay. So I'm going to take everything. Let's see, buffer info. Why is buffer info here? Yeah, it's literally not used outside of this block. So that doesn't belong here. Let's move that. Let's move that there. Did I do the same thing up here? No, I had it correct up here. Okay. So I'm going to take everything after this and basically just move it to the other section and change it to be global. All right, so it's all this. All this. In fact, I'm actually going to take the update descriptor sets with it. Just to make sure that we don't miss anything. Okay, so we'll go up here. And I'm basically going to just replace that. Okay, so in fact, I don't even know if I need this. I don't think I do. So I'm going to get rid of that. Okay, so now we're basically what we're going to have to do is like loop through and make the same updates that we did for instance variables, or instance mappings, rather. But we are going to have to do it for the global state, which is not going to be quite as complicated because we're not going to have to like worry about bound state and all that. But we are going to have to change everything that says instance basically to global. But I don't want to do a find and replace on that because that could obviously cause us to miss things. So global sampler count. This needs to be global. So we're using the correct config. Sampler binding start index, set config. Okay, so we have that. Iterate each sampler binding. So this is going to be global. And then, yeah, we don't have this. So the instance state we also don't have, or the global state. Let's see. So we have in our actual so here's our instance states here. Here's our global stuff here. But do we have, where are the, here we go, global descriptor sets. Where are the actual descriptor? Do we literally not have texture maps here either? I don't think we do. Okay. So yeah, that's definitely a thing. We don't have global texture maps. So we're going to need basically this kind of a setup here. Actually, it's kind of this. So I'm going to do, let's see, global descriptor sets. So I'm going to put all that stuff here. I'm going to take this to do and put it here. So we don't actually need this one because we have global descriptor sets. Vulkan descriptor state. I'm surprised we don't actually have that either for the global descriptor state. Global UBO descriptor state. And then a mapping of sampler uniforms to descriptors and texture maps. So this is Vulkan instance uniform sampler state. But I guess it doesn't need to be instance specific. Right, like this does, but this particular structure really isn't. It's descriptor states, Vulkan descriptor states, and texture maps, and a uniform. So this doesn't need to be instance specific. Okay, which means this isn't. My cat found a toy near my power supply. That can't possibly end well. She's full of it. Okay, so we'll remove this. So we have sampler uniforms. We're going to go with global sampler uniforms. Global descriptor state. Okay. So we have that, which actually is going to cause us to have to refactor a couple of these things. So let me come down here. To apply instance, because we actually have to just change that type real fast. Thought we had it in here somewhere, maybe not. There it is. Let's remove that. Okay. All right, so up here, we have the instance states. So this is going to be the global state. Do we have that? So this is going to be global uniform sampler count, and then we're going to have, let's see, this is going to be the internal global sampler uniforms. Okay. Image infos, this is going to be max global textures. And then we'll loop through the bindings. Let's actually separate this because that's not part of that to do, right? Let me do this down here too. Okay. Binding, sampler state, uniform texture maps. All right, that should be fine. I think all this, the rest of this stuff is pretty much going to drop into place. Okay. All right, so instead of instance descriptor set, we're going to have global descriptor set, which I don't think we actually have grabbed yet. So let's see, where is instance descriptor state? We get that here. Descriptors. Oh, okay. I see. We just grabbed the descriptor set from given the current image index. So global descriptor. Oh, we're already doing that. It's just global descriptor. Probably should be global descriptor set. Okay, so that should be global descriptor set. Okay, binding index. Okay, so that should be fine. I don't think we have any more references to instance in here. We should be good to go. And I could probably separate this logic out into a function instead, and I probably will as part of a refactor, but for right now, I'm okay with it as it is. Okay. So that's actually a good thing, because now we actually have global texture maps that we can use. Alright, let's see what else we broke in this file. I'm sure there's stuff. So, instance resources acquire. So you have the instance state instead of the instance state. We need to go into the sampler uniforms. So let's see. This might actually require some more information. So we have the texture map counts. So here we're just basically passing in a whole bunch of texture maps. Shader instance resources require. So how do we know these what texture maps or what uniforms these texture maps go with? That's the question. Lesser Modernismu, thank you so much for the follow and welcome. Final Fantasy background literally playing right now. It's actually not. So the music here is actually from a game called Heartbound that's currently in development by Pirate Software. And he was kind enough to let me use it on stream. So I will put a link here to that, assuming my bot actually wakes up. I'll just paste this over in the YouTube side because apparently my bot is asleep over there. So you can check that out there. Right. So he was nice enough to let me use that as background music on its stream. So. Oh, you were referring to the wallpaper. Oh. Okay. That? Yes. That is from 14. Yep. Okay. Okay, so the issue here, right, because we were just sort of flatly applying these to texture maps before, is now we actually need a uniform to go with those texture maps. Which is something we probably should have had all along, to be quite honest. Because otherwise, how are we going to know where that needs to actually be associated with it, right? I don't know how to pronounce that, but IRC97, thank you so much for the follow. I appreciate that. Sensor effects, I have to go. Have a great Christmas. See you on Wednesday. Awesome. Yeah, sounds good. I'm getting ready to actually tie up here for the night too, to be quite honest. It's a little bit late, and there's no way I'm going to finish this up tonight anyways. So I'm getting ready to wrap up here soon. But thanks for stopping by and being here. I appreciate it. So, yeah, I guess with that this is probably where I'm going to leave it, right? So I'm going to put a to-do in here. I'm going to put a left off, actually. Need a way to map the texture maps provided here to uniforms in the shader in order to properly assign the texture maps within the new structure. Right. Cool. So that is kind of where we are for right now. We are in a feature branch, so I think what I'm going to do actually is I think I'm going to go ahead and check in what I have so far. That way we have different commits for it, and I can separate what we've done versus what we do next time. So add work in progress, descriptor, refactor. And I guess I can push this. I don't think you guys are going to really want to get this branch yet because obviously this code is terribly broken, but it'll be there if you want it. Cool. So with that, yeah, I think that's where I'm going to leave off tonight. I really appreciate you guys being here. I'm going to drop my social spam here in Twitch chat just to make sure that you guys can follow me in all the places to get any updates or whatnot that occur outside stream hours. And so make sure to follow me there. Make sure to follow me on Twitch and over on YouTube just to get any updates that might come through. Vice Games, thank you so much for the follow. Appreciate that. And yeah, we're gonna pick this up. I think next week on Wednesday is probably when we're gonna be back. We'll see. So I know next week is kind of a holiday week. I don't see any reason why not, but you know, we'll kind of see. We'll kind of see what we're doing, right? So yeah, thanks for the stream. I appreciate that. And coding is weird. Thank you so much for the follow. I appreciate that. I greatly appreciate you guys following me and stuff. And feel free to spread the word about the stream too, right? I'm trying to reach as many people as possible because this is kind of an educational exercise, or at least it's meant to be, right? So, you know, the more people I can reach and hopefully inspire to write game engines, the better, I think. So, okay, so I'm going to look for a raid, and I think I know what I'm going to do for raiding tonight, actually. Let me see. Let me check something first, actually, real quick before I do that. I just want to verify something real fast. Let me check, see. All right. I think what I'm going to do tonight. Yeah, okay. Tonight I'm going to raid Ferret Software. Because it is a ferret rescue that is actually run by Pirate Software. And basically the ad revenue from just people having the stream open, you don't even have to throw bits or anything, is enough to actually pay for the 20 ferrets that he's taken in. It's a ferret rescue because they take in ferrets that were in near-death situations and rehabilitate them and give them all the medical care that they need. And the stream just being open and people watching it, the ad revenue alone has been enough to care for them. And some of those medical and other expenses add up quite quickly. So I think it's a great cause. And yeah, I like to support it in any way I can. So thank you guys so much for being here, and I will catch you guys next time. See ya.